All right, so here we are. This is 152, and we're down to the first part of Chapter 12. Chapter 12 is investigating Windows. Windows is huge and super important, and there's tons of little details you use in Windows, so I broke it into three pieces. So we're going to do the first piece here, and so that's here. All right, and so first piece is NTFS and file system, prefetch, event logs, and scheduled tasks. And by the way, you never learned everything about Windows. I just learned something new last week I never even heard of, elevation. Let me just mention it as in the realm of madness, but this was actually used to turn off the antivirus on several packages, was this thing called elevation. Maybe I can't find it now. There was a way to bypass things using some weird feature of Windows I never heard of that's not in your book. I'll have to bring it up some other time when I can find it again. Let me just give it another second here. It was quite recently. Nope. Should have been here. Anyway, there was more stuff than what we're covering here. There's a lot of weird things that go on inside Windows that can drive you nuts. Next time is the registry, and then other artifacts and memory forensics and stuff on the third day. Anyway, so that was the original system used by floppy disks and then hard disks in the days of Windows 95 and Windows 98. And it was very primitive. It just had, files names had a fixed size of 8 characters, dot, and then 3 more characters, and there was only a little bit of metadata on each file. The files didn't even have owners. There was just like 8 bits of stuff. You could have the archive bit to show that you already backed it up, and like a don't write bit, which was write protect, and a few other bits, very, very rudimentary. So NTFS was the replacement. It came out in 1993 as the new technology file system. And Microsoft promised many times to come up with a new, more advanced one than this, and they never did. They just had a few updates. None of the other things ever happened. So instead of using the file allocation table that has only a small amount of bytes to restore information to every file, they have the master file table, which has a large record to record a lot of metadata about each file. And now each file has an owner and permissions and a bunch of timestamps and all other kinds of stuff on it. So this is the master file table that tells it what all the clusters on the drive are. The drive has clusters of 4 kilobytes in size typically that can store data all over the place, but you don't know what any of them mean without the master file table. The master file table tells you which clusters are in your file. Otherwise you've got random data out there, and a forensic tool will reassemble it into files as best it can, but you won't have file names or owners. So this is your metadata. It's got timestamps, the size of the file, permissions, parent directory, contents, and each volume has its own master file table. It is super important. If you were to corrupt the master file table, all your files will become essentially lost. So there's a backup copy available, and it's stored in the volume root as $MFT, and you can't see it normally. The things starting with dollars are hidden. It's the equivalent of things starting with a dot in Linux. They're hidden because you're not supposed to mess with them because they're essential system files. So you can use Velociraptor to see them, and you'll see here's the MFT, and here's the MFT mirror, the copy of it, I think, recycle bin, log file, and other things like bad clusters, attribute definitions, and so on. So on a standard hard drive, it's got a series of 1 kilobyte entries. So you have a kilobyte to store the information about each file, which is really a lot. And so the first 16 entries are on each volume are the MFT itself, the log file, and more. Those ones you've seen before, stored at the start of each NTFS volume. And you can see it in WinHex too. And you'll see all these. This is the root of C. It'll show you all these auto-generated files with the dollars that are necessary to keep the volume organized, and then a couple normal files created on the volume to go with it. So it's got record types, parent record, active or inactive flag, which is, I think, the only thing that happens when you delete a file. It becomes inactive, available to rewrite. And then other attributes. So you got standard information, file name, and data. And see what it looks like. You got the record header, the standard information here, the file name, and then data in the 1024-bit block available. Let me check for comments in the chat. There are none. Okay. Anyway, so you can get them in Velociraptor. You can run windows.ntfs.mft, and what it will do is parse the MFT and return rows, so you can recover data from the MFT. And now you can get deleted file recovery. If a file is inactive and it has not yet been overwritten, you can recover quite a lot of information about it. So, so deleting a file causes it to be marked inactive. Nothing else has changed. Its contents and its metadata can be recovered. But whenever you create a new file, the NTFS will first try to reuse an old entry. So it will rapidly be overwritten in the normal course of events, typically only for seconds or minutes on the volume. So there's 4 timestamps for a file: modified, accessed, created, and entry modified. And it will have 2 sets of these: standard information and file name. So there'll be a lot of timestamps on each file. And the ones you see if you just go into the properties of a file are the standard information timestamps, and there's only 3 of them you see: created, modified, accessed. This is the only thing you see in the Windows GUI. The entry modified timestamp is not visible in Windows Explorer. You can get it from a forensic tool, and this is a place people often look for evidence of hackers. They change timestamps, but they don't really succeed in changing them all. All right, so there they are. Entry modified is when the MFT entry was changed rather than the contents of the file, like changing the file name, for example. However, the access timestamp, which, by the way, is one of the ones you can see in the GUI, is no longer accurate, which is one of those things that could give you a headache about Microsoft. Ever since Windows XP, they don't update it. Even when you enable it with a registry change, it might be off by an hour. So I don't know why they continue to have this thing that is completely useless and they're just to drive you mad. But there are a lot of things like that in Windows. And generally the reason has to do with history. There's a lot of Windows that really dates from 30 years ago, from MS-DOS, and no longer makes a lick of sense. But you still have these old things left in there. The FN file stamp refers to the MFT entry for the file name itself, and actually maintains multiple sets of these things. All files still have MS-DOS 8.3 file names. NTFS enabled long file names, but it did not remove the old ones. So in fact, you can refer to them by the old one in the command line and get there, but they have a way of connecting to another file which has the long name. Another part of it. So it does not really completely using those long names. In many ways, it's still using the 8.3 file name, and if you execute command line commands with like wildcards in it, you can end up having bizarre results because it's really using the 8.3 file name, and you don't know that. Then there's time stomping. If you want to fix the timestamps, this is the process. If you want to alter these timestamps because you're trying to like hide your tracks, then you can only change the SI timestamps unless you get a special hacker program like setmace that can set them all. And malware droppers and installers all do the time stomping to change them all. Otherwise, you don't get all the timestamps. So the SI and FM timestamps. SI are the ones you normally see, easily altered. The FN are very difficult to modify, so the natural result of sloppy hackers is you'll see inconsistencies between these 2 timestamps because they have forged one, but they couldn't find the other to forge it. And so here's the correct timestamp in 2009. These ones have been stomped back to 2006. So the SI timestamps of these objects have been changed, but the FN timestamps still show the real time in 2009, the sort of thing you might see. All right. And there's a SANS poster with all these Windows artifact analysis with the thousands of things you might find. I think the Velociraptor menu of choices is probably a more handy list of essentially the same thing. All the things you might want to get from your Windows machine. And it's why it's good to have some idea of the names of the common items so you can know what to look for. But it really is quite a maze, especially the registry. Now let's try a Kahoot. I should have them. 12A1. There we go. competition's not too stiff today. Seven people online, okay, but they may not be confident enough to play the Kahoot. It's looking like it's only 2 players. Are you one of them? Oh, you're not. Well, you could get points for free. Anyway. Oh, here it comes. Okay. All right. All right. So which item has the normal modified timestamp? Standard information. This is, for once, a name from Microsoft that actually sounds like it means the right thing. All right, so what replaces the fat in modern Windows? That's it, the master file table. All right, which timestamp is no longer updated? The access point, for some reason. All right, which one is not visible inside Windows? The entry modifier. All right. All right, so data runs. I used to have a lab where people actually manually fixed corrupted data runs in NTFS, but I decided it was a little too insane. Now your forensic tools do it automatically. Things anyway. So this lists all the clusters in the contents. So when your disk is empty, if you store something with 100 clusters, it just puts them right in a row. But if your disk gets full, it'll put a few here and a few there and a few there, fitting the holes. And so they may not be contiguous. This is called the data run. This cluster, this cluster, this cluster would have to be put together to make the file. Now, if you have a small file, only a few hundred bytes, it doesn't put it out in the cluster at all. It puts it in the master file table. The master file table has 1,024 bytes, and it usually doesn't need all that to store the metadata. So your small files are not out in the clusters at all. They're just in the master file table. Resident files. Now, the MFT, therefore, may contain leftovers from previously resident data. When you delete that file and take another file, there may be extra data in the MFT itself, in the 1024 bytes. And I don't know if forensic tools are finding it. I haven't noticed them, but it's kind of screwy. When you're only finding a fragment of a file like that, it's unlikely you're going to be able to do much with it. But anyway, I guess in principle, it might have a whole resident file in there. Maybe the tools do recover it, I'm not sure. Then there's alternate data streams. You can have additional named data attributes, but these point to a series of cluster runs. This was a Microsoft feature added for compatibility with Apple for music. So you would have one set of clusters that had the actual sound. You'd have another for the album art, another for the liner notes, all tied to the same file name. And it used to be a place you could hide malware, but all the modern antiviruses learned about it. And they all share the same timestamps. And you can see them with alternate data streams. And you can write echo world to a file, and you can echo more to treat a file name like a drive, put a colon, and put another file name there. You can use a file like a drive. And now, if you do a directory, it'll tell you only about the main file, not the alternate data stream, but if you dir/r, it will show you the hidden alternate data. So anyway, it's another weird place you can put things. So a lot of these weird little gotchas in Windows. So browsers also intend to stream the downloaded files called zone identifier. If you download anything from the web, it puts this on here, which is called the mark of the web, which is why sometimes when you run things, it says this file was downloaded from the internet and may not be safe. This is the mark of the web. It uses this to determine what it is. All right, and so you can see it here. If I go to downloads, I have iTunes set up. And if I do dir/r, it's got an identifier on it, a zone identifier, to show that it came from the web. All right. So there's a lot of tools to analyze the multi-master file table. SleuthKit, which is part of Autopsy, is there, and there's a lot of other tools that can do this. And there's an index attribute. This is a big sore point at Microsoft. Around the time Windows XP came out in 2001, Bill Gates announced that Microsoft was going to make search engine better than Google within the next 9 months. And the whole world started laughing, and they never stopped again because they can't make a search engine at all. At that time, they had something called Rover the Search Dog in Windows XP that you would open. It would then spend 5 minutes searching your disk and usually not find what you wanted. And Google came out with this thing called Google Desktop that would just open a little box, and you would start typing the name of a file, and by the time you typed the third letter, it found it. It was instantaneous. You didn't even press go. And they humiliated Microsoft like crazy, but they never got over it. They've done many, many things to try to make searching faster, all of which have been disasters. They put one in Office. They tried to index all the Office files that just slowed down your machine, endlessly indexing everything. And they added this index attribute from files to try to make it faster. Somehow Microsoft just can't figure out how to make a search engine. But anyway, so they do have this thing called the index attribute, and it may have metadata, like timestamps from deleted files. So that's somewhat useful for forensic examiners. Let's try 12A2. You can tell from the Microsoft operating system that they do not think logically. They think like a room full of business executives using business terms to get things done, whereas Unix is logical. And that kind of thinking is not going to lead to a search engine. That's my theory anyway. The end result is clear, though. All their attempts to make a search engine have been pretty disastrous. Bing is like the best one they've made, and it's not that good compared to Google. It's popular in China, though, because they obey Chinese law, unlike all the others. So that's what Microsoft is good at, obeying the law, doing a business thing. Not logic. Aha. Well. When the full-time stoner shows up, I guess the party is underway. Everybody comes there. Anyway. All right. Whoa. Well. They may come back. Oh, they came back. I better go before more people flee. All right. So. All right, so which one of these is 1 kilobyte? That's the MFT entry for each file. All right. All right, which one lists the clusters that have a file contents? That's the data. It contains the data run. All right, where are the timestamps for deleted files? X. All right, where do active small files go? Resident data. All right, living inside the MFG. All right. Well, I'm going to step away for a few minutes.